Good morning and welcome to AI Daily. We hope you could peel yourself away from Instagram threads for a few moments to watch us over here, but we will be joining you there on threads. Hopefully later today, you can follow us and then keep up to date with us on the new Threads app, which has been pretty fun as far as I'm concerned. What do you guys think?
I love it. Big fan.
I'm loving it. I think it'll
Yeah,
be
is it a new world or just the same world
absolutely new
over again?
world. What's the difference?
It's so culture.
Here we go. Let's get to the nerdy stuff. And we got a super nerdy story to get started with here. This is a paper about scaling to 1 billion tokens. All right. So this is called LongNet, and they've developed a method to scale transformers to 1 billion tokens. You heard that right. Billion. Somebody sat there and counted every single one. And they do this in some really cool ways. The most important thing that, as you can imagine, they're accomplishing here is instead of dealing with a, quadratic complexity as the as the as the number of tokens increases, they have a linear scaling. So how did they achieve that, Connor? Can you tell us a little bit about that?
Yeah, the normal transformer model uses a pretty simple attention mechanism where it essentially looks at every token you're giving it. That's why notoriously a token windows, context windows have been very small, anywhere from 512 tokens. Most open source models are 2048. And then the biggest models from OpenAI are 16,000 or 32,000. This uses dilated attention, where instead of looking at the entire dense attention of tokens, it dilates out how much it sees in the attention. So although yes, this is technically 1 billion tokens, the way it looks at the tokens is very different from any other type of model. In a sense, it's basically skipping most of those billion tokens and looking at just pieces of them. So is it as useful as 1 billion tokens of GPT-4 context? No, because it's very different.
What can you add here, Ethan? What else is going on with this
Mm,
wacky paper?
Yeah, I think Connor covered it really well. It's an interesting way to say, hey, how can we shove a ton of tokens into this model? But at the end of the day, you're sacrificing performance when you go outside what normally would be the context window. So it might be effective, if you're going for 30,000 tokens and your model's only built for 8,000 tokens, something like that. So keeping close to the window, but nobody's putting in 1 billion tokens and getting good results out of this. So that's kind of the main point you should take.
Sorry to hear that, nerds, but try again next time. It's pretty cool though. I mean, they're
It is.
this is not dumb stuff here that they're doing.
No.
It's pretty clever, and this is attention that I think we've talked about before. There's a trade off with performance versus computational scaling, and getting more smart people thinking about this and trying out different methods is gonna be how we get to the next breakthrough. So it's awesome to see, and congrats to the folks that put that work together.
Yeah, people
Absolutely.
have been trying to do that for a bit actually, but they finally figured out the exact methods to make it work. So it is very cool to see dilated attention actually working in a code base.
Agreed.
Um, but again, I think methods like Alibi or some of those other types of methods are probably the better methods for doing this.
Yeah.
This next story is pretty cool. We love robots over here, and one of the new terms that this paper coins is what they call uncertainty alignment, and it has two things about it that I thought were really interesting. One, there's two tensions in the uncertainty alignment. One is not doing something until you have some sort of statistical sense of guarantee that you're going to successfully accomplish the task. So basically being like, don't do this if you're not sure that it's the right way to do it. But then the other concept is what they call minimal help, basically. So the concept is, if you need help from the user, then do a little bit of thinking and try and minimize the amount of help that you need from the user. So an example they give in the paper is, you tell the robot to pick up a bowl and put it in the microwave, but there's two bowls. There's a metal bowl and there's a plastic bowl. So instead of the robot just being like, I don't know which bowl or which bowl, it'll say, hey, should I take the metal bowl or should I take the plastic bowl? And in that sense, it's minimizing the amount of work the user has to do to help it. And I thought that was a really cool approach to uncertainty alignment. Ethan, anything that you found particularly interesting here?
Yeah, I like how at the end of the day, they're saying, hey, you're not having to fine tune as much. You're not having to do as many like prompt tunings. You're not having to do all this work around it to try to make up for some of these hallucinations and problems. At the end of the day, you're saying, hey, if you're not statistically like set with this, just ask the user. And I think this is, from a meta way, this is stuff people do. If you saw those two bowls and someone said, go pick up the bowl, you're going to say, hey, what bowl? So I think it's not only like cool on a technical standpoint, but works really well from just a UX standpoint. This is the way people think. This is how they work. When you're not sure about something, ask a follow-up question. And you're not trying to engineer it from the very beginning to know which one it should be based on what you've said before. It's just, let me ask and then let me evolve my thinking. So really cool work on this. It reminds me of some of the, think step by step or some of the things you can do with LangChain, asking users, applying it to robotics. Really cool paper.
Connor, you've been accused of being a robot. What do you think?
I have. There's been some comments that have shot those accusations. I'm here to. I can't actually say it. My fine tuning doesn't allow me
We
to
don't
say
want
it.
to say.
My
Yeah.
fine tuning doesn't allow me to say it.
Yeah.
But yeah, you guys covered it pretty well. The no, it's called no, as in understand whether or not. Yeah. It's not, doesn't need fine tuning. It works on a more like framework level where it'll ask whatever LLM you plug into it, and it'll get the top options. And Farb, as you said, for that example, the top options would be plastic bowl or glass bowl, and it'll choose which one is right, and it'll ask the user, which one should I do? It works. Looks like it works
Why
very well.
doesn't prompting solve it?
Because it doesn't, you don't know unless you ask the user. So you have to like get out that question. You have to do some probability for what's the most likely best option. And if the model can't decide between those two options, as the uncertainty thing, as you said, it will ask the user.
Yeah, I mean, we end up in the same place with prompting, is you can't prompt every possible scenario. Uh, you're just kind of back to engineering every possible nuanced edge case that you could imagine, and you're going to miss some. So you're going to get the thing still screwing up if you're just relying on prompting. How big do you guys think this is? It's kind of a small discovery, big discovery? It's going to be like the standard going forward?
I think it's really amazing because they applied it to robotics, of course, like in this paper. But like I said before, I think it's a beautiful UX for if you have a financial chatbot, if you have a chatbot for law, asking the user when you're not sure and getting that follow up is how these models should work. And they showed a great implementation of it, removing a lot of the work that people are doing with these prompt chainings. So I think it's maybe not the biggest discovery, but just a really nice explainer and a new kind of UX for this.
Yeah, what they're doing isn't that crazy new. People have been doing this with prompting for a bit, but how they did it is very simple and very straightforward. They use conformal prediction. They get statistics and probability for what's the most likely, like 4 or 5 options. And then if if one of those isn't high enough, it'll ask the user.
Yep.
And I think that's honestly the simplest and best way you could do this.
It
Clean.
seems like a beautiful and simple formalization of the chain of thought that you have to go through to get to the right result in the end. And I don't know, my gut said that we might see more of this model and approach in the future.
I agree.
It was cool seeing the robot putting stuff in the microwave. All
Absolutely.
right, let's move on to our third story: motion retargeting. This is a method of trying to create three-dimensional avatars from a very sparse amount of input on the user, and that's one of the, I think, interesting things that they're doing here. Basically, they're only taking headset information. So if you're wearing a headset and you have a controller, they're basically just taking that small amount of information and pretty successfully creating 3D, CG avatars of that person. Connor, what did you get from the paper?
Yeah. So as you gave the overall overview, it takes just your headset data of your rotation of your head, of where you're looking, and a little bit of like up and down. But then you can transfer that from the model of a person to the model of any other type of character. The fun part of VR, AR, of course, of all these virtual worlds is that you don't have to actually be yourself. So they showed some pretty cool examples with like a dinosaur, or like a little mouse character, and it can transfer your movements and the real world as a human to these other types of characters. So the way you would walk through a room would be moving your legs like this, maybe quickly if you're trying to move quickly, but a big dinosaur character can move at that same distance by just moving its legs for longer strides. And it outputs very realistic models, very realistic movement. And it looks like it's pretty zero shot to different types of characters. So
Yeah.
What do you think, Ethan?
I like that dinosaur analogy, Connor. You can imagine dinosaurs going like really fast. It would look really unrealistic. So this model touches on like how hard that actually is to do and why you need AI for this. It also reminds me, when we talked about the Vision Pro, they're doing the kind of avatar facial reconstruction. Similar tech, they're taking a lot of sparse inputs from your eye movements, from your head movements, etc. And of course, a little bit different than this, they're going very detail oriented just on your face. And this is being less detail oriented, but over characters and your entire body, but very similar type of tech. And these kind of, the world of sensors that we have, we're not all wearing full body suits. So taking in sparse inputs and actually outputting something that's realistic is important. It's a difficult problem. And I like how they solved it.
It makes me wonder a little bit where it runs into problems. I mean, it seems so good. It seems too good to be true in a way. So immediately my mind is like, okay, well, what are the edge cases where this might fall apart? And, you might be depending a lot on the user.
They showed some like blooper at the end of the video. I don't know if you guys watched like
Oh, I
the
didn't see
video.
that.
It's linked below. But they showed if like the person is like pretending to fall and like leaning back a lot, even if they don't actually fall, the mouse will be fine, but the dinosaur will like flip over completely and not be able to get up at all. It's pretty funny.
Okay, yeah, that's exactly where my head was going. Is you're really depending on the user to maintain the state of this 3D avatar by not, relaxing their hands or relaxing their head or doing weird things. It's not a big deal, of course, but it's just it's pretty powerful, and you can see it becoming a reality. So I immediately start, as a product person, I start thinking, oh my God, what are the problems going to be? That's exactly where you want to be, is moving on to the next problems. And we're moving on to the end of our show. What are you guys seeing today?
Threads and only threads. We covered it in the beginning. I'll cover it again now. It's great.
Yeah, sorry, I didn't realize that you were going to be covering that here. Would you like to read out all the threads that have been posted so far on Threads?
Every single
I
one.
will definitely be linking all of my threads,
Oh, okay.
which are very popular so far. So
Yeah, that's what we like to hear. Connor, what do you think about Threads?
I love threads. I'm a big threads user. I've been
Yeah.
threading all day. I was threading
You've been doing
yesterday.
it for years, I think. You've been on there.
I was actually the first thread user ever.
I made it below user 1 million.
I did
what
too.
number were you?
I think, number 5 or 6. Nobody knows.
Okay,
Yeah.
that's good.
Go
I
look
was
on
3, so that's cool.
Please follow and like. What are you seeing, Connor?
I saw Iron Man. It's like a precision ag, like robot. It's been out for a bit. We've seen some demos and videos of it farther back, but I don't think I've gotten a chance to talk about it on here. It's another cooler video of it. We'll link it below. We'll link it on the side here. But essentially,
That's the weed shooting laser?
it's a giant robot, and instead of having to spray pesticides or herbicides or insecticides, it uses AI to find little weeds or find little insects and like hit them with a laser and just evaporate them, essentially. So very cool. I'm excited about the future of precision ag and how we can use robots and AI to do what we need chemicals to do before.
Yeah,
You're really pushing the robot agenda. It makes you wonder.
Some people have accused me, and again, my fine tuning doesn't allow me to answer. So
No problem. No problem. I'm sure there'll be a paper that allows us to get around that soon enough. I saw the Pi voice. You can now talk to the Pi character. It was pretty decent. The answers were cool. It laughed at something I said. I don't know why it chose to do that, but I actually kind of thought it was interesting. I didn't mean it as a joke. It was maybe mildly absurdist, or just kind of, it didn't know. And so its response was to laugh. And I just thought that was interesting, because people do that when they're not really sure what's happening. They just, and then it went on to explain itself. But it was a pretty cool implementation. Nice work keeping things moving over the folks over there at Pi. Well, that brings us to the end of another exciting episode. Thank you all very much for joining us. We will see you soon on another episode. AI Daily.
see ya.
peace,
Have a good
guys.